Good morning, good afternoon, good evening. Welcome to another episode of Hands-on SAP Dev with me, DJ Q Macro, and you lot out there. You're the people who make these episodes very exciting and interesting, and is the reason why we do this stuff. So welcome everybody. Visas, good morning, well good afternoon to you in Bangkok, Thailand. I've got my phone up there. In fact, I've just realised that I've got the video as well of me, so it's going to be really distracting. I'm just move that. You can move the chat right up there. Very good. So welcome everybody. I didn't put a reminder on the on LinkedIn and other places that this is starting, so I hope people still join, thinking something's going on, and we were told not to do any social media posts, so I didn't put any reminders or anything. I'm very confused. Anyway, so I'm glad that some people have still turned up, so thank you for turning up. Welcome to Matthias, to you in Mesquite in Germany, and everybody else as well. So before I start, let me just post in the chat a link to the SAP Developer News episode for this week. Lots of exciting stuff in there as usual, including a mention of the work that Marianne Zeiss and Wouter Mehr have done in the spreadsheet uploader. You can now use this really cool CDS plugin to upload directly to a CAP backend, which is really cool. So that's the first item in there as well. Sidish, good morning to you and welcome. What else have I got for you? Oh yes. So before I forget, let me while I'm sort of pasting links, let me just reshare a link to. Let me just. I'll go on to the main scene. I'm on this blog post, Functional Programming Resources, which I did share at the start of this series, and it's got a number of sort of links to the FP tag on my blog here. I've got all sorts of stuff I've written about functional programming, and there are various presentations and documents I've sort of picked out and added a short description. The thing I want to base some of our conversations on today is in one of these linked resources, taking the next steps in functional programming. We don't have to read through this now, but if you want to sort of have a look at this afterwards, I'm hoping to cover some of this in here. So that's that. It doesn't matter if you don't look at that. In fact, also we might, given my tendency to digress, we might not even go down that direction. But I think we will. I hope we will, because what I want to cover today, and I'm especially looking to you folks to be active in the chat, to ask questions, and to sort of guide this episode. I want to sort of start covering in a bit more explicit, with a bit more explicit focus, partial application and currying. Now, I have mentioned these terms before. You can write to, sorry, Marianne says, you can write to let YouTube remind you I activated that, otherwise, yes, you can, you can, exactly, thank you. Otherwise, I probably missed. So yes, so Marianne is, you're talking about the reminder bell thing when you subscribe to the channel. That's very good. Yes, excellent. Thank you. In fact, SAP Devs, I think basically, I don't even know. Oh, there, that one there, notifications or something. Oh, or is it here? I don't know. But yeah, remind. I don't know, but yes, basically on YouTube you can subscribe to the SAP Developers YouTube channel, which I hope you are already, and then you can put some sort of bell. You see that in people's videos. Oh yeah, hit a like and subscribe and ring that bell and blah blah blah, all that sort of stuff, which is really cool. So thank you, Marianne, for commenting on that. And yes, so I'm basically hoping to cover these two concepts in a little bit more detail than I would have, sort of waved my arms about before and talked about. And it's also related to closures. So we're going to try and think about currying and partial application and closures all at the same time. I can do that in my app for your live streams. Ah, yes, excellent. Well done, Marianne. And also, Marianne, thanks for posting that blog post that we talked about yesterday on the SAP Developer News episode. It was really cool. So, and I went for a quick run this morning, and I've got to say I'm a bit not worried, but I'm concerned. I want to make sure that I land these two concepts appropriately enough for you all to understand and stay with me. So I want you on the chat to keep me honest and ask the questions and make sure I don't ramble on or digress, and make sure also I explain everything. So please, 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 if you don't understand something, shout. Or if I'm saying something wrong, shout. And I've got this episode from the first episode in the series. Well, I started to mess around here, and I did this thing here, make taxa, and I deliberately sort of did this to sort of put an idea in your mind that you can have like multiple fat arrows. And I started talking about that in terms of closures. So I wanted to sort of just put that pattern in our mind again. I'm not going to go through that, but I want to start there. Now, does anybody know what currying is or what partial application is? Put it in the chat if you have an idea as to what it might involve, what it might be for, what it might look like. And while you're doing that, what I'll do, I want to, oh yes, that reminds me of something else as well. I want to start a new little project, you know, with the NorthBreeze data, with the products data, and we'll use that to sort of base these examples on. Okay, so while I'm here, somebody did ask me about my setup. So I'll just briefly touch on that now. As you can see here, I'm sort of running tmux, etc., right? And I see the windows here. I've got two windows, in fact. But anyway, and this tmux session is running bash, but it's actually running. I'm on a Mac M2, which is an ARM-based chip. So why is this x86 64? It's because I don't often use my macOS natively. I run in containers all the time. So this particular personal development environment, this tmux session, is in a container on a different machine. It's on a machine in my server room, in my electrics room on the boat here. So I can actually just escape out of the container and have a look at the containers that are running. In fact, I've got different Docker engines, so I can look at my contexts. I've got Docker context pointing to different engines on different hosts. So I've got my my NAS over at my sister's house. I've got my home ops, which is the machine, the old Chrome box in there running Linux, Debian Linux now. That's where my tmux session, my container that we're going to be using, is running, and so on. So I can, for example, I can switch to the current context, and then I can attach to one of the containers running there, which is going to be the PD, my personal development environment. So back in there to there. Okay, so that's basically where I am. Anyway, I've got in here just a products.json. So let's have a look. JL products.json, and that is, in fact, we've already got that there. So JL products.json. We've got the NorthBreeze products, which I pulled down, I think, 1 or 2 episodes ago. Note that we've got this sort of first property OData context, and we got the value property, which is the actual array of products. So bear that in mind, because we're going to be using that products data. Okay, so oh, Matthias says translation says currying brush down. Brush down. I'm not sure. Okay. Well, with that in mind, let me define what currying is, and it's going to sound really weird, and then I'll define what partial application is, and then we'll have a go. Maybe we should start with something really, really simple, just to sort of picture it, get it in our minds. Tmux is great. Tmux is basically Tmux and NeoVim and Bash is my IDE. Okay, my working in my PDE, my personal development environment. So currying. In fact, why don't we Wikipedia currying? Here we go. Let's use these words here. Currying is, don't worry about all these weird symbols here. Currying is the technique of translating a function that takes multiple arguments into a sequence of families of functions, that's an interesting way of putting it, each taking a single argument. Now, I've just noticed down here as well, we might as well go here while we're here, currying is related to, but not the same as, I think that's very, very true. It's sort of like the other side of the coin to currying, partial application. So while we're here, we might as well look at partial application. Partial application or partial function application. And before we read the rest of the sentence, basically, function application is where you call a function and pass arguments to that function. Okay, say a function is expecting 3 arguments, you pass the arguments to it, and basically you apply that function, or apply the arguments to the function. So with that in mind, partial application refers to the process, there we go, yes, refers to the process of fixing a number of arguments of a function, producing another function of smaller arity. Oh God, okay. I don't know whether that helps or it makes it worse. So arity is a term for the number of arguments a function is expecting. And partial application and I suppose complete function. Good morning, comrades, says Yavos. Good morning to you, Yavos, and welcome. And function application. Okay, let's dive in. Let's go and I don't know. Let's just say main here, right? So and also I do like this sort of style node. Let's just do that. Change mod plus x main. Okay, fine. So now we can actually run main, which is not going to do anything, of course. Vi main. Also, while we're let's enjoy tmux and say console.log hello world. ENTR. I've used this before. This basically monitors for change. It looks out for changes to a file, and then you can do something. For example, change to a file. So you give it a file name, main, and then pass it to ENTR. I want to say, and then ENTR will run something that you tell it when a file changes, when the main file changes. And you can say run the file that has changed. So if I say now live stream lovely people there. Okay, so this is another way of sort of having some sort of interactive thing, so I can write code on the left hand side and it'll run automatically when I save the file on the right hand side. Okay, so that's all it is. Okay, so I save that, and of course it runs again. There's no output. So there we go. Okay, so now is that big enough? Let's make it big. In fact, I put my head down at the bottom as well because I'm going to write into the top. Let's say we have a function add stuff, and this is a function name that's in that document that I referred to at the start here. So let's use that. Equals. Now again, we could write this A, B, C, return A plus B plus C, like that, and then say add stuff 1, 2, 3. In fact, let's stop me typing a lot of things. Log L equals console.log. There we go. We're even enjoying this idea of functions being first class. Console.log is a function, and I'm assigning that to a constant. So I can actually now say L, right, like that. Oh yes, I've just installed a new sub-module from the mini series, mini NVim. So I should be able to say SA dollar function name L there. Look at that. So now 6. Okay, fine. Right. But what I'll do instead is I'll define it so it's a little bit closer to where we want to get to. Now, first, we've got that. Let's put that there so it's sort of nearer the thing. Okay. Now, here, I have applied that function. I've applied the 3 arguments that add stuff is expecting, and the function runs. What happens, and I think we saw this a while ago, what happens if I don't apply all 3 arguments, if I partially apply this function? Hey Chiara, buongiorno to you and welcome in. Well, in regular JavaScript, let's say, you know, the one we have with Node.js, it gives us not a number. It gives us not a number because 1 plus 2 plus effectively undefined, I could say here, in fact, let's just go back to this thing and say here, let's just do this. Console.log, C is C. C is 3 there, but then if we don't supply the 3, C is undefined. Okay, so we can see that if we don't fully apply a function here, as in if we partially apply add stuff, what we want to happen, which I haven't described yet, isn't happening. And that's because in order to successfully partially apply a function, add stuff in this case, well, what do we expect to happen if we partially apply this function? Well, if we go back here, if we fix add stuff to 2 arguments, as in only give it 2 of the 3 arguments it's expecting, what we expect to receive is another function of a smaller arity, as in a function that's expecting fewer arguments. In this case, one more. Okay. This isn't happening because that function add stuff has not been curried. So that function is not capable of behaving in a way that a curried function behaves, i.e. if you don't give it all the arguments, it's just going to assume that the arguments you don't give it are undefined, as we've seen there. So what happens, and this is all very, very theoretical, and let me know in the chat if you're already thinking, what the hell would this be used for? Okay. Hopefully we'll get to that. It's 8:19 already. If I say, let's go back to, let's just do that again. In fact, no, we don't. We can just leave that there. I'll get rid of console log. Okay, not a number. Now, we need to make that add stuff function so that it's curried. Okay, so we're going to curry that function. And if we remember Ramda, I've seen your question, Yavuz, I'll come to that in a second. Curry, there. Let's just bring that up. let me read Yava's question. Is overloading the same concept? That's a really good question. So thank you for asking that question. No, it's not the same concept. It is, I suppose, related, of course, which is why you asked the question. It's about providing different functions depending on the different signatures that are available for a given function. So it is in the same ballpark as the behavior that you expect when you pass different amounts of different numbers of arguments to a function. But no, it's not the same concept. Overloading is basically where, I think the term overloading comes from the idea that you're overloading the meaning of that function. If if a function takes 2 arguments and it does this, if you define a second version of that function that only takes 1 argument or takes 3 arguments or something, and it does something slightly different, has a different behavior, you're overloading the meaning of that function to do something else, that thing. So hopefully that's an answer that's good enough for now. So it's not the same concept, but it's sort of in the same general ballpark of function application. Overloading is not a term or a concept that comes from functional programming. I think it's arguably more from the object-oriented world. Okay, hope that's okay. Now, Ramda has a curry function. Okay, and the curry function returns a curried equivalent of the provided function. Okay, also remember, we covered this in a previous episode in this series, that all the functions that Ramda supplies, all these functions that do really cool things, all of these functions are curried sort of by default, naturally curried. Okay, but anyway, we're not going to go there right now. We're going to use the curry function. In order to use the curry function, I suppose, let's just bring this in. I've got that there. So let's npm init this thing, and then say npm install Ramda. Perfect. So now const r equals require Ramda. And that H just basically, I think it means, yeah, okay, it's declared but never used, and also a common JS module. I need to sort of, cut down these messages here. Now, all I've done is bring in that library, which brings in all the functions. And all I'm going to do now, let me know in the chat whether you want to keep this sort of function keyword style definition of a function, or go for the more succinct, smaller sort of arrow syntax function style definition. Let me know in the chat whether you prefer this or the one with a fat arrow. I'll keep this for now, and then if you say fat arrow, I'll change it. Now, all I'll do here is wrap that whole thing in r.curry. Okay. In fact, I'm just wondering, it might be easier to read. What do you reckon? What do you reckon? Yeah, maybe. Sorry for asking and then taking my own answer. Maybe it's easy to read if we just have it like that. What do you reckon? That's the same thing. Okay, now I've saved the file. So of course, ENTR has run this script again. Let me get rid of that put up there. There we go. And I've called it. Just like before, I've called it with only 2 of the 3 arguments it's expecting. Now, so therefore I've partially applied that function. But this time, what do we get as a result of add stuff 1,2? We get another function, just like it says here somewhere. We have fixed a number of arguments to 2 to that function add stuff. What we get, what add stuff produces, is another function of small arity. And then we could, I mean, this is a ridiculous example. In fact, let me just put that on a separate line here, just so we can sort of see add stuff on its own, right? Like that. And then, and this is the most ridiculous thing, but we can call that anonymous function here and pass it another argument. Let's run that, 6. But you wouldn't normally do that, right? You know, why would you do that? But I just want to show that because it's possible. So instead, let's say const x, because this doesn't really have much meaning, but x equals add stuff 1, 2. Okay. Like that. So I could do that. That makes a little bit more sense in terms of, oops, not an edited command. A little bit more sense in terms of what you might use partial application for. In this case, we're constructing building blocks. Think in terms of building blocks, functions of building blocks. Oh, so Visa says, I am now liking to use arrow functions in my code by default, but I'm okay with the normal function declaration. Thank you, Visa. Thank you for saying that in the chat. Hope you're okay with using the arrow functions here as well, because I think it's a little bit more succinct and easier to read in terms of, you know, in one go in your brain, right? Now, that's a lot of theory. There's one more thing I want to say before we move from this ridiculously simple, oversimple example of adding 3 things together back to the products thing, which is something, again, we covered. Is it still there? We covered when we did this make taxa thing. And that is this concept of a closure. Remember, in fact, I wonder if closure, no, okay, that's not mentioned there. Closure, yes, in practice the programming, right, yes, perfect. This is a good description. Before we read this, let's have a look at this. When we defined this make taxa thing, make taxa was a function that expected a single argument, %. What that function produced when you would run it was another function that was expecting a single argument, amount. And when you ran that function, as in the function that was produced by make taxa, it would run this bit of code and emit the answer to some calculation. But the key thing is that not only did this calculation involve the value for this particular argument here, amount, but it also involves and would involve the value that we specified for the % when we called make taxa to construct this function. So basically, that is the role of a closure, okay? To close over its, or to include its enclosing scope, okay? So here's a function definition here. Oh, I started playing that. Stop. Here's a function definition here. Amount, fat arrow, amount plus blah, 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 right? But that function definition includes the scope, its enclosing scope. So it includes the ability to get at the value of, for example, PCT, because that's in its enclosing scope. And that's how partial application from a practical perspective works. Because of course, when we partially applied add stuff 1, 2, okay, to create a new function x, that 1 and that 2, those two values need to be remembered for when eventually that newly created function x is called, because of course you're only at this particular point in time giving it the third argument, the value for the third argument, 3. So in order to be able to produce the right answer, which is 6, it needs to still have a reference to the values of the 2 arguments it's already had, the 2 arguments that have already been partially applied. Okay, and how does it do that? Through a closure, through the concept of closures. In fact, we could, this is one more thing before we move away from here. We could define this add stuff, let's get rid of that, like this: const add stuff equals a. So we're sort of going to be manually currying. It's not really, I suppose it is. The effect is similar. Add stuff is a function that takes 1 argument, which produces a function which takes 1 argument, which produces a function which takes 1 argument. Okay. So now we can say add stuff A. When I save that, what we're going to get? Sorry, add stuff A. Add stuff 1. We're going to get a function. Let's pass into that anonymous function that was created from the partial application of add stuff by passing it just 1. Let's pass it 2. What do we get? Another function waiting for, guess what? Its final argument, the C, there. Now, this is only illustrative because, yes, it has the same feeling as partial application and currying, and in effect it sort of is, but it's like, you know, a poor relation, because what we can't do is something like we did before. In fact, let's do it exactly the same. So const x equals add stuff 1, 2, and then call x with 3, right? What do you think we're going to get? Let me make that big. We can make it bigger, can't we? What do you think we're going to get? Let's save it. We're going to get an anonymous function, because basically add stuff has not been, quote unquote, properly curried. Okay, it's not something that's flexible enough to realize, you're giving me 2 functions. We have sort of rigidly defined add stuff to be a function that just takes a single argument. So when we call add stuff, it's going to ignore this argument number 2 here. So if I now say x3 and then say I don't know, 4, we get 8 because it's 1. The 2 is ignored because there's no parameter here to take 2. 3 gets assigned to B, and 4 gets assigned to C. 1 plus 3 plus 4 is 8. Does that make sense? Okay. Let me know in the chat if you're still there. In fact, I can see if you're still there. Oh, got some viewers. Amazing. Still there. And by the way, that thing that's highlighted here in the video here, this is a more interesting example of the use of partial application. Again, we're still not properly, this is not a properly curried function, but we're still effectively using it in the same mental space. We're partially applying this sort of series of, you want a percentage, an amount to produce some calculation. So we are now constructing or creating add VAT as a function. We're defining on the fly dynamically such that we're fixing 20 to be the value of percent, 20%, and make taxa brackets 20 will produce a function, an anonymous function that we then assign to the add VAT constant, that is expecting an amount. And when we pass the an amount 100 to add VAT, I suppose we can do that, can't we? Add VAT, there, 120. Does that make sense? Let's go back, and rather than watch videos together, let's go back and start messing about with products. Because let me just remind you of what's it, next steps. Yeah, that's it there, yes, next steps. What I want to do is start having a look at a more practical example. Okay, so let's build that up ourselves. We don't need that anymore, it's confusing us. It's confusing me rather. Let's move that over here a little bit because a bit more space. Now, we'll leave Rando, we'll leave console log. We'll have, remember we've got this products thing, right? So const products equals require products JSON dot value. Don't need that, don't need that, don't need any of that. Log products. Let's just have a look. Okay, fine. Fine. Now, notice that if we look at the first one, we get the product ID 1. Okay, this is from NorthBreeze, right? NorthBreeze products. Product ID 1. So the first one has product ID 1. So actually what we'll do, I've seen your question, your comment, Matthias, I'll answer that in a second. So what we'll do, in fact, if we say products 1, we get, obviously index 1 because it's 0 indexed, but this is ID 1, 2, 3, etc. So what I'll do actually is let's create an array of with an empty object in it and concatenate it with. So we sort of unshift onto the end, effectively, an empty object, so that products of 0 is going to be that empty object, but products of 1 is 1. Okay, makes sense. Right, anyway, Matthias, so it is possible to build functions which can be partially prepared by... Yeah, yes, Matthias, you've got it, exactly, yeah. I mean, I'm sorry for not saying that sort of explicitly. One of the key powers of what functional programming provides to you as a developer is the ability to build up functions, almost like build a DSL, a domain-specific language. It's not all about DSLs or anything, but to build up functions that A, you define, B, are pure, C, are static, still solid state code, and then you can use these in different sort of combinations to put them together, compose them. We'll talk about compose next week based upon hopefully what we're looking at today, so that you build up effectively a library of functions that make sense to you, that you know work, that you know are not going to break. There's no moving parts. They are pure. Again, we talked a little bit about pure functions. Pure functions are basically functions that literally, whatever you input, that influences the output, but they're not influenced by any other values anywhere else in your code. You know, it's just a black box. And this is where we get the idea of, or where the idea of referential integrity comes in. If you've got a function that takes an input or some inputs and produces an output, if you in your code replace that function with the value that it emits, and your program, the whole program still works, then that is a pure function, because all it does is operate on the explicit inputs you give the function at the call and produces, and it doesn't have any side effects. It doesn't change anything elsewhere. Okay. So that referential integrity and pure function concept is also part of what you're saying here, Matthias, which is you want to build these things static, that are statically defined. Maybe static is the wrong word here, or it's overloaded, and you can put them together and compose them. Again, I keep saying this word compose. We'll talk about what compose really feels like next week. Is that okay, Matthias? Okay, so we've got this products, and let's say we've got child do, and we want to see. In fact, let's use the console table. There, okay, so we can see chai has a category ID of 1, which I think is beverages, right? Whatever. So there are other products that are in that category. So let's say we wanted to find products that had the same category as chai. So if we break that down, we'd end up with a function which was in that, somewhere in that document, right? Const has same. Okay. Now, what do we need from an argument perspective to work out whether one particular product object has the same value for, in this case, category? We're just going to pick category. No, we need, for example, what property we're talking about. So it's going to take a property argument. We need to have, we're talking about, is this given product the same as far as category goes as this reference product? In fact, why don't we say const reference product equals product of 1, right? Oh, that's obviously not going to work, but there we go. Let's just say t reference product. There, that's the reference product, okay? So now, this has same also will need to know what's the product, what's the reference product here. And then finally, and the order of the arguments here is important, okay? We haven't really discussed argument order, and this is to do with point-free coding as well, but we'll talk about that again hopefully next week as well. We need an argument that we can use to represent the product under test, let's say. Now, let me just finish the function definition, and it's going to be a predicate function, i.e. something that returns a Boolean. does the value of the specified property in the product under test, does that have the same, we could use triple equals, I suppose, does that have, let's do double equals, does that have the same value as the same property in the reference product? Okay, in the referred to product. Now, so far so good. So we can say has same category ID. You can tell this comes from a CAP OData service, right? And then I'm going to use the reference product constant, and then I'm going to say, I don't know, products. What have we got here? Let's just see what we've got. We've got product ID 2. That's got the same category. Product ID 3, honestly, so that's also a liquid, isn't it? Here we go. Product ID 4, Cajun seasoning. That's obviously not a liquid. That's got category 2. So let's try it with product ID 3, which is category ID 2. Interesting. Seasoning, syrup's a liquid. Anyway, I don't know. All right, let's just do product ID 2, which has category 1, and product ID 3, which has category 2. Okay, so products of 1, and then let's just also just wrap that in T. There. True. Now, let's go to the end and try aniseed syrup, which has category ID 2. Or let's try the syrup's doing my head in because that's a liquid. I don't understand why it's in category 2. Anyway, let's go down to the bottom and say Cajun seasoning, product ID 4. Okay, that'll do. 4. False. Okay, so far so good. But where is the relevance of, where is the appearance of partial application, currying, and so on? Well, we haven't done that yet. So if I were to not supply our product under test, what are you going to get? An error. Cannot read properties as undefined. Classic JavaScript error, because at the moment this has same function is not curried, and therefore partially applying it is not going to work, because as I'm sure you all know, if you don't supply, as we've seen just in the add stuff thing, if you don't supply an argument that's being expected, then the value for that expected argument that's not been supplied is undefined, right? And that's what we get. Cannot read properties of undefined. It's trying to read the property category ID of X, which is undefined. So let's curry that function. Okay, let's curry that function. Now all I've done is curry that function. DJ, stop saying curry that function. I'm going to save it. What? Oh, I forgot to put the enclosing arrow, sorry, there. I've now curried that function properly. I'm going to save it. And now we get this function anonymous, but we now get A, what that is, and B, why it is. That is exactly a result of calling has same with only 2 of the 3 arguments that has same is expecting. And according to the definition of partial application generally, but also as we saw in the Wikipedia, very nice and concise, what we get back is a function that's waiting for the next argument. So we could say, for example, now, just going back to what you said, Matthias, const same cat category as chai, right? Equals has same. In fact, we've got it there, haven't we? Yeah, there we go. Let's move that over there a minute. There. There. Same cat as chai. In fact, yeah, that'll do. Has same, yeah. I'm just thinking of the name. Has same cat as chai, because it's a predicate function at the end of the day. So is or has as a prefix to the function name makes sense, right? Makes sense to me anyway. And now we have, so what have we done? We've got a curried function. We've partially applied that function, providing it with some values. And remember, when we partially apply that function, we get another function waiting for the final argument in this case. But this anonymous function includes the ability to reference the values of these two arguments, prop and ref, because it's in the enclosing scope. So this anonymous function that's waiting for this third and final argument of here, waiting for the x, has category ID as the value of the first thing, prop, and has reference product as the value of the reference product. So as soon as we products 4 is the one is occasion seasoning, that's got category ID 2, so it should be false, right? False. But the beautiful thing as well is that we could say, let's just do that on a separate line here so that we can just sort of write it out like this. Products dot filter, right? Has same cat as chai. Let's just log those out for a second. Let's have log and table. Log. There. Has same, and then actually what we'll do is map r.prop. Let's just do that because it's crazy, right? Prop product name. This is just a random function that will just give us there. Okay. So we've constructed, again, going back to Matthias's really good point here, we've constructed this helper function that only makes sense in the context of our program, right? It's almost, this is where I was meaning about a DSL, domain specific language. This is a thing. It's a function that we've constructed by partially applying another function. But notice as well what is happening here. Because there's not magic that's going on, but there's something that's going on that I haven't explicitly mentioned here that is based upon the fact that we deliberately chose this order for the arguments. Because we've now partially applied has same, providing arguments for prop, which is sort of fixed, as it were. Ref, as in the reference product. And we haven't supplied the argument value. Sorry, we haven't supplied the value for the argument that is most changeable, as in you're going to be wanting to try that product, or that product, or that product, or that product. And that is a very important concept as well about argument order, especially when you're currying function, when you have curried functions and you're partially applying them, because it allows us then to use this newly constructed on-the-fly function, has same cat as chai, in a solid state coding way. Because what is going on there? What's going on is the same as, you know, I can sort of expand this out as, because a filter expects a function. It expects a predicate function to which it will pass, each time it iterates over all the elements of products, it will pass one element at a time. So this is the same as saying X has same cat as chai X, right? Same thing. But because has same cat as chai is already a function that's expecting one argument, the third and final argument of the partially applied curried has same, we don't need to do this. Oops. We can just write it like that. Okay, does that make sense? Right, I think that's probably a good place to stop here because it's 8:57. We're just scratching the surface of the beauty and the power of curried functions and partial application and construction of functions based upon partially applying other functions, and then the use of those constructed functions in situations like this. Fine, you know, a stupid example more is we could do const product name equals r dot prop, by the way, prop there. It just returns a function that when supplied an object returns the indicated property of that object. Okay, so it's the same sort of thing. Prop product name, right, like that. And then we can say map product name. Same thing. I mean, if we wanted to define this without Ramda, right, let's just leave that there as a sort of reference. Product name product name is basically takes a product name property and then returns something that basically is expected and returns that, right? That's the same definition. Oh, anonymous function. What am I doing? Product name. Product name. And then, get property, right? And then we can say const product name equals get property product name, right? There. So these two things are equivalent. Okay, 8:59. Thanks for listening. Thanks for all your questions. And Matthias, that was really useful. And also Yavuz, great question. And Visa's great question as well. Oh, Yavuz, this is fantastic. Really interesting. Raul, welcome. And hello. Visa's, wow, I just discovered the currying concept for the first time. Looks interesting indeed. Thank you very much. So have a great Friday. Have a great weekend. We'll use this as a basis now to think about composition. Putting these building blocks together to make even bigger building blocks. Okay, that's it for now. Bye, folks.